All right, next video from the June 2011 Regents. This is going to look at the true response questions from 56 to 61. All right, this first question, 56 and 57, this is a nice little softball question here. We have calculate, so we know we're using a formula. We're calculating kinetic energy. All right, so we need our kinetic energy, and your kinetic energy is equal to 1/2 mv squared. Let's see what we got here. Particle with a mass of 3.34 times 10 to the negative 27th kilograms. Well, that's a small mass, but that'll work. So that's 3.34 times 10 to the negative 27th kilograms. And we have a speed. Oh, that's a very fast speed. V equals 2.89 times 10 to the 5th meters per second. All right. So let's plug these numbers in, and let's see what we get. So that kinetic energy equals 1/2 times 3.34 times 10 to the negative 27th kilograms times 2.89 times 10 to the 5th meters per second squared. All right. And then time to break out the calculator. So we got 1/2 times 3.34 negative 27th times 3.8. And looks like our kinetic energy is very small. So Ke equals 1.39 times 10 to the negative 16th joules. All right, let's see if we got everything. Show all work, including the equation. Equation we got right here, substitution with units, unit, unit, unit. Good to go. So number 58 is telling us that we have a circuit with a 100 ohm resistor, and we're putting another resistor into the circuit, and we want to find the smallest equivalent resistance that we can get. So if you want to make your equivalent resistance smaller, you need to hook these resistors up in parallel. So if you're hooking resistors up in parallel and you're finding equivalent resistance, you're doing 1 over Req equals 1 over your resistors. So we have 1 over 100 plus 1 over 25, and that equals, this is 4 over 100, so that equals 5 over 100 equals 1 over 20, so Req, that is an EQ, equals 20 ohms. Boom. Number 59 is interpreting a graph, and it's asking the physical quantity represented by the slope. Slope is rise over run. So let's look at the rise. The rise is work. So we have work over the run, which is time, and work over time, if you look on your reference table or if you remember, is equal to power, which is your final answer for 59. Lastly, 60 to 61 is asking us to calculate. Oh, there's that word calculate again. Okay, that means we need to use a formula. So calculate the power dissipated by this heating element. So we need to go and find a formula for power that relates to volts and ohms. And the formula that I would recommend is power equals V squared over R. And so now we just need to plug this in, so that's 12 squared. Oh, and let's do this correctly. 12 volts squared divided by 1.2 ohms. And that's going to give you 144 over 1.2. And that, get your calculators. 4 divided by 1.2. is 120 watts. All right, let's check it. Do we show all work? Yes, we do, including the equation. We got the equation, substitution with units, unit, unit, unit. We're good to go. 2 out of 2.